Okay guys, so this is the free response problem from your unit packet. That is excellent preparation for tomorrow's exam. Very similar to a problem that we've worked out before. I'm noticing right away that this function, which P.S. here's a typo, should be g of x equals, is defined as the integral from -2 to x of f. That's hugely helpful because just based on that, I can draw conclusions about g prime and about g double prime. Based on what we talked about the other day, forgive my bad handwriting, g prime of x using the second fundamental theorem of calculus will equal f of x, and g double prime of x based on that relationship I can now claim is f prime. That's going to be very helpful for parts of this problem. But let's dig into part A and see what we need to think about for this. The first thing I'm asked for is g of -6. Which is not too terrible because the g of x function is given to me. So I'm going to need to be looking at the definite integral from -2 to -6, of f. I can do a little bit of computation. First thing I notice is that my bounds are upside down, so I need to rewrite them in the correct order, but notice I placed a big negative out front. Now, when I look at this, I've got the definite integral from -6 to -2, which is basically this triangle right here. My area is negative because I reversed the bounds. Base times height, that's 4 times 5, 20 over 2, so -10 is the answer to my first definite integral. Okay, I'm going to do the same thing now for g of 3. That's defined for me then as the definite integral from -2 to 3 of f of t. No need to flip my bounds here because they're in the right order. So I just start accumulating area. Let me change colors. It's going to be this semicircle and this baby little triangle here at the end, which notice is negative. So the semicircle formula, that's going to be pi times my radius squared over 2. The radius here is 2, minus that little triangle, which is going to be 1/2 the base of 1 and the height of 2. Because this part's going to be free response, there's no need to do anything else with your answer. If you're dying to get something simplified, it's 2 pi minus 1, but I wouldn't recommend it. Okay, so first part is all area computation. From here, the next part of the question, part B, asks for g prime of 0 and g double prime of 0. That's 100% based on these relationships we established at the beginning. This should not be a difficult question. G prime of 0 is the same thing as f of 0, which notice is the graph that I'm looking at. So at 0, there's an output right here at 2. F of 0 is 2. 1 point is earned. I don't need to do anything else. For g double prime of 0, I'm noticing that that's f prime of 0 according to my relationships. Derivatives, don't forget, mean slopes when we're looking at a graph. And on this graph, if I hone in at 0 and ask myself what the slope of the tangent line is right there, I'm excited because it's a horizontal tangent line, so my slope is 0. And there I have 2 additional points earned in part B. Okay, for part C, we're asked to determine now where G has a horizontal tangent, and then determine if those places are maximums, minimums, or neither, and justify our answers. Again, the big relationship that we already established is that g prime is equal to f. So one thing that's really important here is that when we see this phrase, horizontal tangent, the annotation that we always used to make for that is that that means g prime has to equal 0. Since g prime is really f in this case, then I need the roots of this graph. Be careful because a lot of people want to include -6, but my window here does not include -6, so I cannot count that root. So looking at this, I see a root right here and another one right here. So the first thing I'm going to do is just say that the horizontal tangent lines exist at x equals -2 and x equals +2. And that's because g prime equals 0. So from there, I've established 1 point. Sorry, someone's talking in the background, so listen carefully just to my voice. Okay, so now we can look a little more specifically and try and do our classification. Notice that at -2, your graph of f or g prime is above the axis on the left and above the axis on the right. Therefore, there's no change in sign. So for x equals -2, we're going to have neither. At x equals -2, because g prime does not change sign. At x equals 2, however, I do notice right here that I'm starting off on a positive side and then making a transition as I cross through that root to the negative. So there's definitely a change in sign here. And specifically, I've got a positive value followed by a negative value. So I've got a max at x equals 2 because g prime changes from positive to negative. Forgive my handwriting, guys. I forgot my stylus, so I'm using my finger. Okay, for part D, the question is asking us to determine points of inflection for G. So again, thinking back to our stairs, if G has a point of inflection, that means G prime changes from increasing to decreasing or decreasing to increasing. So since I'm looking at G prime, that's going to be specifically what I'm looking for. I notice that change right here, increasing to decreasing. Another change at -2. Sorry, I don't know why that keeps happening. A very subtle change at 0. And that's it. No other changes. So these are my 3 points of inflection. I've got one at -4, another at -2, and a third at 0. And that's because G prime changes, increasing to decreasing, or decreasing to increasing. Full credit with my justification and my 3 identified locations. I'm going to go ahead and close out this video and come back with part E and part F in a new link just so that it doesn't take forever to upload. Please feel free to fast forward and navigate and rewind and replay if you need to revisit anything that happened in parts A through D. I cannot stress enough how aligned this is to the free response that you'll see tomorrow, so it's really in your best interest to study and make sure that you understand where I'm coming from on all of these problems. I'll see you back in a second for the last 2 parts.